In the third part of this video on the Java Collection Framework, we will discuss some of the most frequently used class methods in the Collections class and provide an example that illustrates the use of the sorting methods. Before we introduce the class methods in the Collections class, we begin with an explanation of comparators, which need to be passed as parameters to some of those methods. Let's begin with an explanation of the purpose of a comparator. One instance in which it is useful to create a comparator is for classes that don't implement comparable. By creating a comparator, objects of such classes can be compared. A second instance in which it is also useful is for classes that do implement comparable. In that case, creating a comparator makes it possible to perform the comparison in a different fashion. Comparator is a generic interface that contains one method, a compare method, similar to the compare_to of the comparable interface. The signature of compare is slightly different from compare_to. Because it is not a method in the class whose objects are being compared, it requires two parameters, both objects that are being compared. It should return the same kind of integer value as compare_to, which is a negative value when the first object is smaller than the second, a 0 when they are equal, and a positive value when the first object is greater. Now we are ready to discuss the collections class. The collections class, not to be confused with the collection interface, is what is sometimes referred to as a utility class. Like the math class, it contains only class methods, methods that are declared static. We will consider several of the methods in this class that accept list objects as parameters. The first is the sort method that accepts only a list as a parameter. This method is actually a generic method whose generic type is the type of the elements in the list. That type must implement comparable because it uses the compare_to method to perform the sort. The second method is another overloading of sort. This method requires a second parameter, which is a comparator. It uses the compare method of that comparator to perform the sort. The next method we have chosen is the binary search method. Like the previous methods, it is also generic. We have simplified the signatures, omitting those details. But what is required is that the elements of the list again implement comparable and that the type of the key be the same as the element type. As the name suggests, the reverse method reverses the elements of the list. And finally, the shuffle method randomly shuffles them. This method would certainly be useful when implementing games. Our example illustrates the use of both of the sort methods that we just described. It will sort a list of employees that are input from a file. We begin with the definition of the employee class. Notice first that the employee class implements the comparable interface. It contains two instance variables, an employee name, which is a string, and an employee ID, which is an integer. It contains one constructor that allows those two instance variables to be initialized. It contains the compare_to method mandated by the fact that it implements comparable. It makes the comparison by comparing the employee names. Scrolling down to the remaining methods of the class, we have included an overridden toString method to facilitate outputting employees, and finally a getID method that returns the ID. We will see shortly that this method will be used to define a comparator for this class that compares employee objects based on the ID. The program reads in a file of employees, adds them to a list, and then sorts the list both by employee name and by employee ID. This comparator is defined to compare the employee ID instead of the employee name. Notice that because comparator is a functional interface, we are able to use a lambda expression. It is also a generic interface, so it must be constrained by the type employee so that the parameters will be of that type. Finally, observe why we needed to define the getID method in the employee class. Without it, we would have been unable to create this comparator. The employee records will be stored in this array list, and then it will be sorted in two different orders. Let's scroll down so we can examine the remainder of the main method. In this loop, we read in the employee name and ID pairs from the input file, and using them, we create an employee object which is then added to the array list. First, we sort the list by the employee name and then output the sorted list. Then we sort it by employee ID using the comparator that we defined. Then the newly sorted list is output. Next, let's run this program. Notice that the list is indeed sorted according to the two different keys.